So the next test is the urea hydrolysis test. And the urea hydrolysis test is a test that checks to see if your bacteria contain an enzyme called urease. Basically, if your bacteria have an enzyme called the urease enzyme, that means they can break down urea. If your bacteria are lacking the urease enzyme, that means they're not able to break down urea. There are several bacteria that do produce the urease enzyme. Quite a few bacteria that produce the enzyme are able to cause urinary tract infections like the Proteus bacteria. And then there's another type of bacteria called Helicobacter pylori, which can be found in your gastrointestinal system, not everyone's, but in some people's gastrointestinal system, and it actually causes gastric ulcers. But Helicobacter pylori is known for the production of the urease enzyme. So basically, the urea test is a test tube test, and it's basically this liquid broth, and inside that liquid broth there is urea, and if the bacteria, again, have that urease enzyme, that means that they're going to be able to break down urea. So the urea test actually starts off this orangish color. So that's just what color it is naturally. It starts off orange. And if you put your bacteria in there and your bacteria have the urease enzyme, they are going to break down urea. And when urea is broken down, ammonia gets released. And that is going to cause the pH in that test tube to go up. This test tube also has a pH indicator, and when the pH goes up, this test tube is going to turn bright pink, which is what we see here. So with this test, bright pink is a positive result. Bright pink means that yes, your bacteria have the urease enzyme, so it was able to break down urea, which caused the pH in the test tube to increase, which would have caused the pH indicator to turn bright pink. If your bacteria does not have the urease enzyme, then urea would not get broken down, which would mean that ammonia would not be released, which would mean the pH would not change. If the pH doesn't change, one of two things can happen. Either the test tube will turn yellow or it will stay orange. Regardless of whether it's yellow or orange, those are both negative. So pink is positive. That means your bacteria had the urease enzyme and can break down urea. Orange or yellow is negative. That means your bacteria did not have the urease enzyme and it was not able to break down urea. This test does have a time limit in which it needs to be read, and that is 24 hours, so I would want you to remember that. The reason why it needs to be read within 24 hours is because if it gets left in the incubator too long, remember the incubator is what we use as kind of a temperature chamber to encourage growth, so it's typically a bit warm in there. If it gets left in the incubator too long, the heat can actually break down the urea and cause the color change to happen, even if it was supposed to be a negative result. So if you put a bacterium in there that does not have the urease enzyme, you would expect that it would be orange or yellow when you take it out of the incubator. But let's say you leave it in the incubator for 48 hours. Well, the heat from the incubator could break down urea and cause it to change bright pink. And that would actually be a false positive because it wouldn't have been the enzyme that broke it down. It would have been the heat. So with this, you need to read the results within the 24-hour time period. As long as it's read within that time period, then yes, pink is positive, and then yellow or orange is negative. So the last test is the blood agar test, and it is, as it says, it's an agar plate that contains blood in it. It's typically sheep's blood. Sometimes they do use horse blood. And basically the point of it is to see if the bacteria that we put in there are able to harm the red blood cells, because there are bacteria that can destroy red blood cells, and those bacteria can be quite dangerous sometimes. But there are different types of what we call hemolytic activities. Basically, some bacteria can produce these toxins called a hemolytic toxin that allows them to destroy red blood cells in some way. So there are 3 different types of hemolytic activities. The first is beta hemolysis. Beta hemolysis means the bacteria produces a toxin that completely destroys the hemoglobin within the red blood cells. So it pretty much completely destroys red blood cells. So this is kind of worst case scenario. Streptococcus pyogenes, which causes strep throat, is known for its beta hemolytic activity. So it's able to produce a beta hemolytic toxin that can completely destroy red blood cells. So when you put a beta hemolytic bacteria on a blood agar, you'll see something like this, where the blood has been completely destroyed and cleared out. So it's almost like you would kind of see a zone of inhibition. You would see like this clear area around where the bacteria were growing, where the red blood cells have been completely destroyed. So the main thing to know here is beta hemolytic activity means the red blood cells have been completely destroyed. So then there's alpha hemolysis. Bacteria that produce an alpha hemolytic toxin are going to partially break down the red blood cells. So not completely, but they partially break down the red blood cells, and they actually cause kind of this pale green growth to occur. And this is quite common for bacteria such as E. coli. So if you put a bacterium on a blood agar plate that has alpha hemolytic activity, again, it will partially destroy the red blood cells and cause the blood agar to turn this kind of pale green color that we see here, which is common for something like E. coli. The last one is gamma hemolysis. Gamma hemolytic activity is actually no hemolytic activity. This would basically mean that the bacteria did not produce any toxins to affect the red blood cells in any way. So it's kind of the absence of hemolytic activity. This is common for Staphylococcus epidermidis that's just naturally found on your skin. If you put a bacterium on a blood agar that has gamma hemolytic activity, it's just going to grow on top of the blood agar, but it's not actually going to do anything to the blood because it doesn't have the ability to affect the red blood cells in any way. So it just grows on top of the blood agar, but does not actually damage the blood in any way.